Here we go with translations. This one is my favorite one because if you can count, you can translate. So a translation is a function that maps a point to its image along a vector, and we'll talk more about those vectors in a little bit. It's called a translation vector, such that each segment joining a point in its image has the same length as the vector, and the segment is parallel to the vector. Have you guys ever seen the movie Despicable Me?
Yes. Yes.
Do you remember the villain Vector?
Yes.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Ever seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh! Ah! It's so difficult sometimes to get the piranha back inside.
Mr. Brew, Mr. Perkins, you see now?
So that vector has two things. The vector needs to show both direction and magnitude, meaning like which way it's going, and the magnitude is like how far it's going in that direction. So these look a lot like rays, but they don't go on forever. They just go on for a certain amount of time. So the vector is going to tell you both of those things. So that definition of translation says that it's going to have the same length as the vector, meaning it's going to travel the same magnitude, the same direction, and it's going to be parallel to the vector, meaning it's going the same way. So we have both of those things going on. This is an example of a vector where it's showing you that it's kind of going like up and to the left, or sorry, up and to the right. And then this point is going that same direction for that same distance. There's two ways that we can write vectors out. For function notation, it gives you a coordinate, and it'll simply say what you're adding or subtracting to that. So maybe it's x plus a and y plus b, and these are just going to be numbers. You could also be subtracting from those, and if you like this way, you can just use this and just add numbers to all of your coordinates or subtract numbers to all your coordinates, then graph those points, and you'll have your translation. This is the less popular way to have it written because it's more work than writing it as a translation vector. So a translation vector is going to have these like two, kind of looks like a less than and greater than symbol, these two brackets, and you're just going to have whatever A and B are within that. So these would be the same numbers. Okay, so for example, let's say I wanted to move to the right 3 and down 4. If I wanted to take a point and move it to the right 3 and down 4, the function notation would say x, y. So any coordinate, you're going to take and you're going to add 3 to move it to the right 3 to the x part of the coordinate. And you're going to need to subtract 4 to move it down 4. This same example in component form, or writing it out as a vector, would simply be 3 -4. This is my preferred method. Okay, so when we're doing these translations, what I like to do is I like to just count them out. The one thing you have to kind of make sure you get straight in your head is this is not the same thing as slope. Slope, we do rise over run. This is different. This first value is your x part of the vector. So this is telling you how you're moving the x value. So because it's +2, you're going to the right 2, or you can think of it as like x plus 2. The x part of the coordinate, you're just adding 2 to it. And then this one here, it'd be like y minus 4, or that would be down 4. So what I do is I just take each point separately and count to the right 2 and down 4, and then just make sure that you're labeling those. So to the right 2 and down 4, to the right 2 and down 4. You should end up with a congruent transformation in the end. And again, if you have some different colors, that might be helpful. That's a thicker line, but that would be a congruent transformation. Nothing's changing size with it. Okay, for this next one here, the x value is 0, so that's meaning it's not going left or right at all. And then this y value, -7, means we're just going to go down 7. So from each one of those points, you can just count down 7. And label them. And there's your translation there. Feel pretty good about this? Okay. If you want to pause the video and do these next two on your own and then pick it back up, that might be helpful, and just kind of do it as a double check. If not, you can watch me do the next two also. So for this next one, we are going left 4 and down 3. So each point, just go to the left 4 and then down 3. So it is a little different than slope. We're going left or right first and then up or down second. So left 4, down 3. Make sure you're labeling these as you go also. Left 4, down 3, and left 4 and down 3. We should end up with a congruent transformation when we're done. If you want to get a straight edge or something to use to get those right on, that would be great. And then for this last one, this is a +5, so that means I'm going right 5 and up 2. So each one of those, 1, 2, 3, 4, 5, up 2. To the right 5 and up 2. To the right 5, up 2. And sometimes once you get a few of them on there, you can just kind of see where the other ones are supposed to go. If you're not quite sure about that, feel free to, count it out again. But that's essentially what we're going to be doing with translations for the most part. Yeah. Okay, so for this last example, it's just showing us, it says a coin is flipped using stop motion animation so it appears to move. So if this coin were being flipped, we want to talk about like what's happening. This first one says describe the translation from A to B in function notation and in words. So function notation is where you have like the x, y, and then you're showing what's happening. So when you go from A to B, you have to describe how that x part's changing. Well, the x value is adding 3, so I would put that that's x plus 3. And the y value is it's going up 2. So I would say that that's y plus 2. And then if I wanted to write this out in words, I would just say, you know, maybe like the translation is going right 3 and up 2. It's just kind of like the way you would say it to somebody if you were helping a friend out, how you would word that. And then the next one, this one here wants us to go from A to C, and this is using a translation vector. So that translation vector is where you just kind of summarize it with just those 2 numbers. So from A to C, it's going over 1, 2, 3, 4, 5, 6, 7, and it's going up 1, 2, 3. So I could say that that translation vector is 7, 3, and that is that.